In this video, we'll walk through the Trailmark API Quick Start for engineers integrating for the first time. By the end, you'll have an API key, a successful authenticated request, and a clear model for handling errors and rate limits in production. Before you start, you need a Trailmark workspace on a plan with API access, team or higher, and a developer or admin role. Without those, you won't be able to create API keys. Start in the Trailmark app. Go to Settings, then Developers, then API Keys. Click New API Key. Give it a descriptive name, something like Internal Reporting Pipeline. This name matters later when you audit usage or rotate keys. Next, choose a scope. Use the smallest scope that fits your use case. Read Workspace is read-only. Read-Write Workspace allows non-billing rights. Admin Full includes billing and should be limited to admin tooling. Click Create Key. The key value starts with tm_live_. You will see it once. Copy it immediately and store it in a secrets manager. Trailmark never shows it again. If you lose it, you must rotate the key and update every system that used it. Now, let's make a request. All Trailmark API calls use the base URL https://api.trailmark.com/v1. Authentication is via a bearer token in the authorization header. The format matters. It is authorization:_bearer, one space, then the key. The fastest sanity check is the workspace's me endpoint. Here is the curl request you should see on screen. Curl https://api.trailmark.com/v1/workspaces/me with an authorization header set to bearer tm_live ... and accept application/JSON. If everything is wired correctly, you get a JSON response describing your workspace, its ID, name, plan, member count, and creation timestamp. That confirms end-to-end authentication works. In real systems, do not hard code the key. Read it from an environment variable, set request timeouts, and treat the key like any other production secret. Here is the minimal Python example using requests. We call the same endpoint, pass authorization bearer with the value from the Trailmark API key environment variable, set a 10-second timeout, then call raise for status so non-200 responses fail fast. And here is the node version using fetch. Same idea. Pass the authorization header. If res.ok is false, throw with the HTTP status so upstream code can decide what to do. Now let's talk about what breaks. A 401 unauthorized means auth failed. The header is missing, malformed, or the key is invalid. Most often, the bearer format is wrong. Check that it is exactly bearer, one space, then the key. A 403 forbidden means the key is valid, but the scope is insufficient for that endpoint. The fix is operational. Create a new key with the required scope, or use an existing key with broader scope. A 404 not found means the resource does not exist in your workspace, or the identifier in the URL is wrong. Double-check IDs and workspace context. A 429 too many requests means you hit the rate limit. Trailmark includes a retry after header in seconds. Respect it. Sleep for that duration and then retry. 5xx errors are transient server-side failures. Retry them with exponential backoff. If they persist, check status.trailmark.com. By default, Trailmark allows 600 requests per minute per workspace. Every response includes rate limit headers. X rate limit limit tells you the limit. X rate limit remaining tells you how many requests are left in the current window. X rate limit reset is a Unix timestamp for when the window resets. Your client should read these and pace itself. If you want to see them directly, run curl with the -i flag to include headers. You will see the X rate limit headers on every response. Finally, implement safe retries. Automatically retry only 2 cases. For 429, read retry after and wait exactly that long. For 5xx, retry with exponential backoff and a cap. Everything else is a hard failure. Fix the request, fix the scope, or fix the resource ID. At this point, you have the full baseline integration. You know how to generate a properly scoped API key, authenticate requests, interpret the common error codes, and build rate limit-aware retries. From here, move on to the full API reference or the official SDKs, which handle retries, pagination, and rate limiting for you.